Pandas data frames can be loaded from and saved to different file formats, such as comma-separated value files, Excel spreadsheets, JSON, and XML files. Let's look at a tab-separated value file named waste.tsv. We view the first 12 lines of the text file using the shell command head, preceded by the exclamation mark. This file was downloaded on October 22, 2018 from the Eurostat database and contains the amount of waste generated by EU countries categorized by economic activity, waste category, and hazard. First of all, we can see that the text file is a mixture of comma and tab-separated fields. The column specifies the year, while the row specifies the unit, the hazard, the economic activity, the waste category, and the country. We can also see that missing values are indicated by colons, and in the very last line, we can see a value followed by the letter S. It turns out that several alphabetic characters are used as footnote markers to indicate that the value is, for instance, an estimate or a forecast. We can choose to either remove the trailing letters or to exclude these values from our analysis. First, we use read table to load the text file, specifying that the header is the first line and that the separator is either a comma or a tab. We also specify the parser that we want to use, in this case the Python engine. Now we load the table again, and at the same time we rename the columns by specifying a list of strings and integers using the option names. When we call the argument shape of the data frame, we see that we have loaded a rather large table of 12 columns and almost 300,000 rows. If the column name is a string, we can select a column simply using DataFrame.columnName. We then use unique to list all the waste categories which are repeated multiple times in the column named waste. With reference to the Eurostat database, we rename some of the waste categories. Here we use Boolean masking to filter rows with a particular name. We start by renaming W074 to plastic waste, and we rename other interesting categories as well. To make our data exploration easier, we do the same for the activity labels. Using the type function, we notice that all the values are strings. We can force pandas to interpret the strings in the year columns as numerical values using toNumeric. Specifically, we apply the function toNumeric to the last 7 columns of the data frame. The numeric characters are interpreted as float64, and by setting the error option to coerce, non-numeric characters are replaced by not a number. If we instead want to keep the values followed by footnote markers, we use apply_map to strip alphabetic characters at the end of the string, and after that we apply toNumeric. Apply_map applies a custom conversion, here determined by the lambda function, to all elements of the data frame. Now that the data is tidier, we can save it to another format, such as an Excel spreadsheet or a comma-separated value file. Boolean masking can be used to look at the amounts of plastic in kilograms per capita generated by German and Swedish households in the various years. This way of querying the data is rather cumbersome. Luckily, Pandas provides hierarchical indexing, which allows us to represent this data as a 2D data frame. In this case, we want to promote the first 5 columns of this multidimensional dataset to indexes. We do that using the method setIndex, specifying as keys the list of labels of the columns we want to promote to index. The resulting data frame has 7 columns, while the strings of the former first 5 columns are now the indexes ordered hierarchically from left to right. The same transformation of the data frame can be performed more explicitly by first creating the index from the underlying NumPy arrays using the multi-index method called fromArrays. The index is then specified as an argument when we create the new multidimensional data frame. When we index the new data frame, we get a performance warning. Indexing a data frame with lexicographically unsorted index levels is inefficient. To solve this performance issue, we use sortIndex to sort the index levels. We can now query the data frame without obtaining the performance warning. Notice that the indexes have to be specified following the hierarchical order.